Hello, thank you for coming. The work I'm presenting to you today is part of my undergrad research at UBC as part of the Environmental Sciences program. And I was analyzing changes in Aleutian low strength frequency analysis from a 1,000-year-long marine sediment core. Now, first of all, our location is at Effingham Inlet, British Columbia. Now, it has restricted bottom waters, leading to ideal conditions for data interpretation from the cores. And as you can see, our site is right here. There have been a number of cores taken from that area. First of all, what value does this research have? Well, as introduced in the prior talk, the climate index PDO has been identified, and it's based on the instrumental record, which only exists with high confidence for the past 75 to 100 years. What if we could trace it back further in time? We could check whether this is a recent phenomena, if it has changed with time, and possibly link it to other phenomena. Traditionally, most of the tracing back has been done with tree rings, but we need to establish more proxies if we want to go back further in time, especially with the uncertainty regarding the tree ring divergence problems. So here is how I'm able to tell you how the climate varies based on sediment brought up from the deeps of Effingham Inlet. Our initial research has led us to believe that these assumptions are validated. However, we don't have time to walk through that today. Now, the Aleutian low strength is influenced by processes such as PDO and ENSO. In our core, we don't have the resolution to actually see ENSO, so that makes things a little easier for myself. It then influences precipitation. As the Aleutian low strength increases, so does precipitation. And those signatures are captured in the delta C13 values that's influenced by the runoff from the banks into the inlet. So a quick recap on PDO. It's climate index, climate anomaly index, I should say. And it occasionally undergoes regime shifts, such as in 1945 here, when it goes from positive to negative, and then in approximately 1977 here, when it goes from negative back to positive. The influence then, when it switches sign, becomes the polar opposite of what was currently being felt in different locations. So the Aleutian low is then influenced by cyclic processes. Now, for those of us unaware, this here is the Aleutian low, and this is the California high. Effingham Inlet is right on a steep gradient in between the two, a steep gradient of influence. This here is the sea level pressures. As the strength of the Aleutian low changes, so does the influence upon the location and the amount of precipitation. So, increased precipitation due to increased Aleutian low strength. Now, this subsample of our core is an X-ray from approximately 342 to 610 BP. It's an example of what we call well-laminated sediment, so we get excellent data from these regions. To us oceanographic climate researchers, these are our tree rings. So, we dated sediments using terrestrial material from within the core itself, giving us high confidence in our data. And that consists of multiple geochemical analyses spaced over an average of 5 years. And that yields us the delta C13 values that are more negative, also known as lighter, as precipitation increases runoff, as precipitation increases the runoff from the banks. And this here is our raw delta C13 values. Now, variation in that record is influenced by the origin of the organic carbon. A pure marine signature is actually considered around -21. So no matter what, whether it's a very negative PDO or very positive, we still see terrestrial influence. Now, if we match that up with some tree ring chronologies that have been used to study PDO frequency during the same time period, on a first order approximation, there are some areas of high coherence, and then over here we have some areas where they're not as coherent between the three data sets, I should say. These may be either attributable to regional effects, methodology effects, or other unconsidered elements, but it's still valuable to consider their frequency results in comparison with any relationship they may have with ours. Give you a second to soak that in. This is my analysis. As a clarification, these are the frequencies of cyclic signals seen in the raw delta C13 data that I just showed you. What I did was I conducted a Fourier analysis on 350-year bins, beginning in 1002 AD and overlapping the bins with a new one every 10 years. I then compared them chronologically using this analytical output for frequency variations with time. So how this works is, on the x-axis here, we have, for instance, this 500-year marker. That is actually a bin of 350 years where the analysis was conducted. So that 500 BP marks 500 plus or minus 175 years analyzed with the Fourier transform. I then plot it here with the periods on the y-axis. So as the strength is high in these red areas, that means these periodic signals are present.